left one is conventional tool.
Yes, left one.
Normal X-axis cutoff. Right one is Y-axis cutoff too. Three times
Three times
faster.
faster.
And cutting point is much higher than original ones.
Big effect. Hello, machinist. I'm Sho Nakamura from Nakamura-Tome.
Hello, machinist. I'm Hiro Kuratani, Nakamura-Tome.
So today we invited special guest. So Mr. Kono from Sandvik Coromant company.
Thank you so much for having us today. My name is Fumitaka Kono from Sandvik Coromant. Once again, thank you so much for having us with you today.
Mr. Kono, today our non-stop machine talk.
Yes.
Episode 6.
Episode
With
6. Yeah, that would be really great. And
Okay.
then, you have introduced our solution, our silent tools in the previous movies, and then we are so excited.
That's
So
right.
that is why we came over here to bring some of the latest solutions from Sandvik Coromant.
And at that time we talk about how about Sandvik Coromant company will collaborate with us in the YouTube video. Today our dream come true.
Yes.
Okay. So today, so we will talk about the machining video and the machining scene.
Yep.
So provided by Sandvik Coromant company.
Yep.
We can stop
Yes.
this machining
Yep.
and then we can talk.
Yes.
Okay. Let's start. Okay. What is that? Coromant QD.
Yes. So we have today we have brought the cutting of tools. Designed especially for the multitask machines and turning centers.
Okay. This is a cutoff tool.
Yep.
And left one is conventional tool.
Yes, left one.
Normal X-axis cutoff. And right one is Y-axis cutoff tool. But
Yes.
already finished. Stop. Oh, difficult.
Difficult to stop.
Stop
It's
it.
too quick.
Already finished.
Very fast.
Wow.
fast.
X-axis cutoff process still
Still
keep
going on. Yeah. Of
So-
course, improving the productivity is our DNA in our company.
Really?
So, and
Very
then this
good.
is one of the examples of how we can do the cutting of operation much quicker than previous.
Okay. So, Mr. Kono, this
Yeah.
is a normal
Yes.
X-axis cutoff tool.
Yes.
This is
The Y-axis.
Y-axis.
So Y-axis parting off.
So, what the name of it? Coromant?
It's a Coromant QD,
Coromant QD.
and then Y-axis.
So why we can do so fast Y-axis cutoff?
Yes, the challenge of the cutting of operation is always the long overhang of the tools.
Okay.
So that will limit us of the increasing the cutting data.
Mm-hmm.
Because cutting off requires the overhang to machine this diameters.
Okay.
You know, the normal X-axis operation, then you get the cutting force directly vibrating the tools.
Right.
So with this Y-axis parting off, you have the insert looks like this,
Yeah.
and then the cutting force will come from this direction,
Mm-hmm.
and then we have a turret here.
Okay.
So the robust part is supporting the overall cutting operation. So that will prevent the vibrations,
Okay.
chattering, and then in the end of the day, we can increase the cutting data to this level.
So your idea is utilize a good base.
Yep.
The turret,
Yes.
tool spindle, and the base is strong for
Yep.
cutting force.
Absolutely.
Of Y-axis cutoff.
Yes.
Wow, that's nice. idea.
That's a concept. Yes.
Mhm.
But thanks so much to the machine tool makers like you that you have created the Y-axis movement, and then we came in and then we brought the tool.
Once I saw this like operation,
Uh-huh.
I like this one. So means
Oh.
customer like this operation
Uh-huh.
because cycle time quite shortened and very fast,
Mhm.
and cutting point is much higher than original ones.
Ah, really? So our company Nakamura-Tome
Yep.
use this technology, I think a little bit faster than the other company.
Right,
That's
you're
the
right.
history, right?
Yeah, you're right. Because our machine has,
Uh-huh.
of course, Y-axis machine. Then we are thinking about how we can use Y-axis direction. Then they have good idea, so I catch up
Ah.
very quickly and starting the test cutting, everything, take a video and show to the customer.
Uh-huh.
The customer very happy to us to understand the big
Thank
Coromant.
you so much.
So everyone, why so Hiro love to go to Sweden? What's the name of the town of the hometown for the Sandvik Coromant company?
Sandviken.
Sandvik.
Sandviken
Wow.
is the place where Sandvik Group has started.
Yeah, I hope to
I-
visit.
Yeah, we most welcome.
No visit yet?
No visit.
No visit yet.
3 times I visit.
3 times.
Yeah,
Thank
3
you.
times.
Very jealous.
Yeah, we talked about that, and Hiro-san visited our company much longer than I did. He spent more than 1 month in Sandvik. So
Yeah,
really
right, you're right.
So let's start again. Okay, this is the y-axis cutoff already. So finally, and done.
Yeah.
Oh, what is that?
Stop. So you see the cutting data.
Yeah.
So
Yeah.
Hiro-san already explained this, but you can focus on the feed rate
Yeah.
of the revolution. The conventional parting or the cutting off normally operates in the 0.15 millimeter per
0.15, yeah.
revolution. But with y-axis parting, we did 3 times faster the feed
Three
rate.
times
3 times
faster?
faster. 0.45.
Wow.
So that's what we can do. And then, of course, not only with our cutting tools, but together with the y-axis capable machines, then we can do this.
This is a big effect, Hiro-san.
Yeah, the diameter is cutting like a diameter 80 millimeter. X-axis cutting is a 60 second,
60 seconds.
but now means a 20 second, I think.
20 seconds.
Yeah.
20 seconds.
3 times faster than
3 times faster.
all
So
of them.
that's a big effect. So if we achieve
Yep.
3 times faster, so takt time for the machine, so we need to increase the cutting, the feed rate
Yep.
and the cutting condition. We change the tool and
Yep.
many things.
Yep.
That is very tough. But if we adopt this kind of technology, we can achieve this result.
Very-
That's very good.
Very good, very quickly.
Oh, yeah. So how about the material side? Do you have a limitation on the material?
Not really. I mean, as Hiro-san mentioned, this is a normal parting
Okay.
or cutting of so that you can change the insert
Okay.
to suitable materials.
Mhm.
The video is showing like a higher steel.
Okay.
Swedish standard, I
Yeah,
see.
Swedish standard SS. But of course, you can do the stainless steel. Then
Yeah.
you can change the insert,
Mm-hmm.
adapt to the stainless steel, etc. Then you can do
Wow.
the similar things.
So if the material changes,
Yeah,
just
then change the insert.
Wow.
Yes.
That is a nice technology.
Yep.
Okay. Let's go to next. Oh, this is the insert or the turning tool. Oh, this is a round insert. Wow. This is another y-axis turning.
Yes. Stop. This is another y-axis, as you rightly said.
Mhm.
So we use the same type of technologies.
Yeah.
That the cutting force will go direct to the spindle part,
Mhm.
so that you can increase
Okay.
the cutting conditions. And then here we put the 2 different inserts, and then you will see the movies,
Okay.
how it
Okay.
moves. So,
This is another y-axis.
yes,
turning.
y-axis. So this is y-axis turning. So
Turning.
y-axis.
Oh. Oh, this is a y-axis
Yes.
direction.
So the same concept.
Uh-huh.
The cutting force is more towards the spindle part.
And
then you
also
do the
reverse cutting.
reverse cutting. So this is a prime turning concept.
Oh.
So prime turning insert is on.
This is a prime turning. It's a
Yes.
very now
Yes.
famous
Yes.
cutting method, right?
Yeah. We have some another unique ideas of feeding into the different
Uh-huh.
directions. And then
Stop. Also, the cutting chips is really nice shape.
yes,
So
Not-
turning
not
and the
wrong.
long cutting chips. That is a technology of also the chip break.
chip breakers, and then of course the entering angle of the insert is also designated, so that you can run the feed rate faster, and then you can have a better chip
Okay.
break.
So you change the angle always appropriate.
Appropriate.
The breaker section.
Absolutely. That's a key.
And also how about the cutting condition? That is the feed rate 0.45.
4.45. Yes.
Very
Again.
fast. A very beautiful cut.
Right.
Okay.
Cut of dips about 2 millimeter. Oh, it's nice. Yeah.
Mr. Kono, you said this is a y-axis turning method.
Yes.
So the concept is, I think, it is similar
Yep.
to y-axis cutoff, this prime turning tool,
Yes.
and because of y-axis have the base of the unit,
Yes.
that kind of direction
Yep.
is ideal for the high cutting,
Yes.
load cutting resistance.
Yes.
So that kind of concept is which one is more early, so you make this kind of development.
Yeah. Actually, the first step was to really launch this
Oh.
concept. The
Okay.
cutting off is the first one.
Okay.
But of course, we have so much potential here on the y-axis. We come up with this, and then this is like a y-axis capabilities, and then this is a y-axis plus the multitask machines. So
understood. So This is a big brother.
Big brother. And
This
then
is
this is a younger
medium or
brother.
small
Yes.
brother. Looks like a big brother, but
Yes, yes.
a very interesting
Yes,
history.
yeah.
Okay, let's start again. Oh, tool orientation.
Wow.
Ah,
Nice.
very
That's
smooth.
good.
So it means tool orientation is by tool spindle orientation,
Yes,
right?
yes.
Okay, this is round insert.
Round
Mm.
insert.
Wow, this is also very fast.
Very fast feed rate, isn't it?
Yes, yes. So basically, normally the round insert
Yep.
have the capability of increasing the feed rate, but very often it's challenging to control the chip. So the chip gets really long sometimes, and that's the difficulty. But you can see like in
Right.
this video,
Very
chip
fine.
control is very
Yes,
fine.
very
So,
good, very good.
No stop, etc.
Feed rate is 0.6.
0.6.
Stop.
Okay,
This is maybe something like a Toolpath.
Yes. So this is the so-called the dynamic turning tool passes. So
I see.
we together with the CAM suppliers, we have created this kind of like a tool pass. As I said, like increasing the feed rate, making the grooves without any long chip problem. So that you can see like a lot of like a circle. So that all the tool paths are quite smooth.
I see.
oh, it's very interesting. How to make this program?
So normally we recommend to use the CAM
Okay.
software. But I heard that you also have the solution to create a tool path for this.
Yes, we can do that.
In our machine, and of course, the customer use a CAD/CAM, and also customer use a cycle. So without CAM software, so that easily to apply this kind of the nice technology for our machine.
Yeah, you're right.
Okay, let's start again. Oh, nice this grooving shape. You have the so R on the bottom,
Yes.
very smooth. And
then
wow,
we-
what
we-
is that?
We index the tool again.
Wow.
And then this D-shaped tool came back. And then do the final finish.
Oh, that's
Again,
interesting.
Again, using the orientation of the spindles.
Wow, it's a nice idea using not only y-axis but also orientation axis of
Yes.
the two fingers.
Yes.
Oh, super smooth. Well, finally, I want to stop
Stop.
here. So, these two, now you use this round, the insert, then you orientate, so these two,
Yes.
by two spindle function,
Yep.
then use the finishing.
Finishing cut. Yes.
It's mean you combine the many process to one tool.
Yes.
Is that so easy to put the magazine? Also
Absolutely.
reduce the number of the tool
Yep.
or machine?
Yes.
Wow.
So
That's
utilizing
nice idea.
the magazines is one thing. And then of course indexing the tools
Yeah.
is like a seconds. So
Wow.
that it's very quick.
Very quick.
So cycle
That's
time
idea.
and then efficiency of the utilization of magazines. These two are the benefit for the customer.
Oh, at that time also you don't need is this tool spindle go to the magazine,
You go to the
and
magazines
change the
and change the
tool.
tools.
That is also reduce
Yeah.
the chip to chip time.
Absolutely.
So Hiro, what do you think about the customer user scene for using this kind of nice technology?
Yes, actually this one is a roughing and finishing, right?
Okay.
And also the grooving, big grooving
That's right.
area, and also standard facing and the turning area. Just one tool. So it's very good for customer. And
Yes.
so the customer has a lot of idea, I think.
Yes.
If once we show to the customer, maybe customer want to this tool. I see. I
That's
guess.
good. This is the big brother, is the y-axis cutoff tool.
Yep.
It's for the pallet machine and
Yes.
tool spindle machine.
Right.
And this prime turning tool
Mm.
for tool spindle machine because need orientation.
Right.
Yes.
If the customer want to reduce the cycle time and on the tool spindle machine, it means the automated the tool spindle machine concept and put the many workpiece and many type of workpiece and many tool on the magazine and then want to reduce the cycle time. Wow. I think with your imagine, you have the many potential to use this kind of nice y-axis technology with multitasking machine. Hopefully, our Nakamura-Tome multitasking machine. Right? Okay, let's finish the movie. Okay. Wow, that's orientation again. Then final facing.
Yes.
Wow, it's a beautiful machine. So, the machine finished. Also, the Sandvik Coromant companies, this kind of video is very beautiful. Isn't it?
Right. I love this video and I want to try to same video.
Oh, really?
Thank you.
Not the same.
That's it.
So try to learn the technology. So with Sandvik Coromant company, so Nakamura-Tome, we always offer the unique and nice idea for customers' factory. So let's cut the value of manufacturing with all together. So, Mr. Kono, you have the plenty item today.
Yes.
So we never stop talking.
Yes.
You wanna talk more?
Yeah, I want to talk more. I really want to talk more about
Okay.
what we have. But in the next episode, we have the next episode. Thanks so much.
Oh, okay.
With the next episode, we will talk about the silent tool.
So don't miss it next episode. So if you like this video, please subscribe and press high rating. See you, machinists. Bye.
Bye bye.
Bye.
Bye. Love.